Hi everyone. Welcome to today's tutorial, question 17. How to improve SQL query performance using indexes. Before we dive into real-world business scenarios, let's first understand two primary types of indexes in SQL Server: clustered indexes and non-clustered indexes. Clustered index. A clustered index determines the physical order of data in a table. Since it controls how rows are stored, it's most efficient when used on a column that uniquely identifies each row, like a primary key. However, it's not mandatory to use the primary key as the clustered index. You can choose any column or combination of columns, though it's best practice to use a unique, non-null column. Pros of clustered index. Efficient for range queries. Because data is stored in index order, retrieving a range of rows is faster. Speeds up sorted queries. Queries that require sorted data benefit because the engine doesn't have to sort again. Cons. Slower insert, update, delete operations. Because maintaining the physical order requires extra work during modifications. Only one clustered index per table. Because a table can only be sorted in one way. Key characteristics of clustered index. Defines the physical order of rows. Only one per table. Ideal for range queries and sorted retrieval. Now let's move on to non-clustered index. A non-clustered index creates a separate structure that points to the actual data rows. Unlike clustered indexes, it does not change the physical order of data. You can have multiple non-clustered indexes on a single table, allowing you to optimize queries on different columns. Each non-clustered index contains the index columns and a pointer or row locator to the actual data row, which may be a row ID, primary key, or clustered index key. Pros of non-clustered index. Faster retrieval for non-primary key queries. Great for lookups on columns other than the primary key. Supports multiple access patterns. Because you can create many non-clustered indexes for different query needs. Cons. Consumes additional storage, especially on large tables with multiple indexes. Slows down data modifications. Each insert, update, or delete may trigger index maintenance. Key characteristics of non-clustered index. Data rows are not physically sorted. Contains pointers to actual rows. Multiple indexes allowed per table. Ideal for filtering or sorting on non-primary columns. Adds storage and maintenance overhead. Do we need to create a clustered or non-clustered index? In fact, if you create a primary key or unique constraint, without specifying the index, SQL Server automatically creates a clustered index. If a clustered index already exists, SQL Server will make the primary key non-clustered. If you explicitly define a non-clustered index, SQL Server respects your choice. If you create no indexes at all, the table becomes a heap with no defined order or index. Now let's see how to create indexes in SQL Server. To create a clustered index, we can use the following code. Create clustered index name. On table name, column name, ASC or DESC, in which index name means the name of the index. Column name means the columns to be indexed. ASC or DESC shows optional sort order. Default is ascending. To create a non-clustered index, we can use following code. Create non-clustered index name. On table name, column NME. Same structure. Just define it as non-clustered. Now, let's apply this to a real business scenario. We'll use the query from question 15, which retrieves the most recent order for each product and part number. When we ran this query without index, it took 3 seconds to get the result. Since this query involves a join, a rank, window function, and filtering by RK equals 1. We can optimize it by creating a composite non-clustered index on the orders table that supports the join and the window function. Given that we have thousands of products and millions of orders, the orders table is the real bottleneck. Let's clear the cache and create the non-clustered index. Create non-clustered index 9_orders_product part date. On orders, product number, part number, order date, DESC. This index helps by speeding up the join. SQL Server can now quickly seek on product number and part number, supporting the order by order date, DESC inside rank, allowing SQL Server to retrieve data already sorted. After creating this index, the query runtime dropped to 1 second, just 1/3 of the original time. Conclusion: properly designed indexes can drastically improve your query performance. Always analyze your query patterns and create indexes that support your joins, filters, and sorts. But be cautious. Unnecessary indexes can slow down data modifications and consume storage. Thanks for watching. If you found this video helpful, please like, comment, subscribe, and share this channel. Thank you.